Okay, this is going on page 46 when we're done. So we're going to do a little warm up here. We're going to review doing the synthetic division from yesterday. So this says you have this function and the remainder when f of x is divided by x minus 9 is 1, then we want to find the value of k. So one thing that differs here from yesterday is that we have a k value in there. And we could use long division here, but I would say that synthetic division would be better, right? And I highly encourage you, when you're able to make that decision, if you know how to do synthetic division, which you should, that you use synthetic division. Had somebody yesterday on the very last question that we did on the notes choose to do long division, and I didn't stop him, and but I kept having to catch little things that he did. It wasn't that he didn't know what he was doing. He brought the wrong thing down, or just simple little things that we're all capable of. Anyway, he said, yeah, I didn't want to do synthetic division. I'm choosing to do long division. So I'd let him do it because I just wanted him to make sure, and he practiced. He was halfway through anyway. But by the end, everybody else that had done synthetic division was done. They'd taped it in, whatever. He was still working on it when the bell rang. And so I said, in the end, so do you think maybe you want to change what you really kind of want to do on these? And he was like, yeah, I think so. So I think he became a believer. Again, not bad. It wasn't that he was clueless. It was just there's a lot more room for error there. So if we can use synthetic division, that's what we're going to do. So if I'm going to divide by x minus 9, what do I put on the outside of the house? Positive 9. Good. So then inside the house, we always check for missing terms, right? Stuff's always crooked. This is x to the 4th, so I should have 5 numbers in here. I have 1, 2, 3, 4, 5 terms, so that'll be taken care of. So my first one is 7, then negative 63, then 5, then k, because it's just a constant, and then negative 80. Right? And then under that, I put my little basement. What else do I know that I can put in here before I start my synthetic division? The remainder is 1. It tells me the remainder is 1, so I'm going to put a 1 in there. I already know what it is. Okay? So then we're going to run through our synthetic division, bring down the 7, that makes this 63, that makes this 0. We don't freak out. 0 is good. 0 makes it easier, right? 9 times 0 is 0. That makes this 5. 9 times 5 is 45. Then I have to decide what to put right here. Am I going to put 45k right here? No, because 45k means you're multiplying. Did we multiply these two numbers to get 0? No, we did not. We added them. So think about it's the exact same process. There was no multiplying. We multiplied 9 times 7, but then when we added these. So this is just k plus 45. So then I do the exact same thing. I multiply 9 times k plus 45. So I got 9 times k plus 45 right here. Okay? Now, I need to figure out what k is. Do I have something that I can set up as an equation? Yes, I absolutely do. It's right in front of me, right? I'm adding these two to get what's down here. So I know that negative 80 plus 9 times k plus 45 equals 1. Do we all agree with that? I could have put 9 times k plus 45 minus 80. It's the same thing either way. So I'm going to start by moving 80. I'm going to add 80 to both sides. So I have 9 times k plus 45 equals 81. Now, do I have to distribute this 9? No. And since I don't have to, I don't want to, because I don't want to do 9 times 45, right? So instead, I can divide. So I get k plus 45 equals 9. And then k equals what? Negative 36. Look, I'm basically taking 45 minus 9, right? So 45 minus 5 gives me 40. Then I subtract 9 more. It's negative 36. It's like the hardest question of the day. Okay. What questions do you have? Anything? Okay, so just another little application of synthetic division. All right, now let's see what's going on here. It says, consider this polynomial. And the first thing it says for us to do is just to divide by x plus 4. So can I use synthetic division? Yes, so I think I'm going to. So I'm going to put negative 4 out here. Inside, I'm going to put 1, 1, negative 4, and 41. I want to make sure I didn't miss anything. It's x cubed. I should have 4 numbers. I'm good. All right. They didn't give me the remainder. There is no k, so this is just plain old synthetic division. So I should be able to run through this pretty quickly. Bring down my 1. This is negative 4, negative 3, 12, 8, negative 32, and then 9. Okay. So that means then that what this gives me is x squared minus 3x plus 8 plus 9 over x plus 4. Okay? Again, just a little warm-up review of yesterday. On B, it says to find f of negative 4, which means I substitute it in. So f of negative 4 is equal to negative 4 cubed plus negative 4 squared minus 4 times 4 plus 4 times negative 4, sorry, plus 41. Okay. Just substituted it in there. So when I do this, negative 4 cubed is negative 4 times negative 4 times negative 4. Is that going to be positive or negative? Negative. And then 4 times 4 is 16. 16 times 4 is 64. And then negative 4 squared is going to give me a positive 16. This is going to give me another positive 16. And then plus 41. Now, when I combine these, I can combine them in any order. So I want to think, I know that 16 and 64 are related to each other, right? So I'm going to combine these two first, and I'm going to get negative 64 plus 32 plus 41. And even if you were doing this, and I mean, you wouldn't necessarily always have to write it all down. I just don't want to lose you in the thought process. So then what's negative 64 plus 32? Negative 32. So I've got negative 32 plus 41. So f of negative 4 is equal to what? 9. Okay. Now look at the two things we just did with the same function. Do you notice any similarities there? I mean, the work is completely different. That's a bad way to say it. Do you notice any common numbers anywhere? 9, right? F of negative 4 is 9. We find 9 here, negative 4 here, and 9 here because it's the remainder. See how that works? So we have something called the remainder theorem that if you want to evaluate a function, like if I want to evaluate the function at negative 4, I can do the synthetic division. My remainder is 9. Would you say, and it's a matter of opinion, but would you say that this was a little quicker and easier than this over here? Yeah, and what if it wasn't negative 4? What if it was negative 12 and we didn't have a calculator? That would be a nightmare, right? This would definitely be better, even if the numbers got a little big. It wouldn't be nearly as bad as that over there. Now, what I wrote in pink here is irrelevant for that, but it doesn't matter. We didn't know that. We were just following what it said. But this is where the remainder theorem comes from. Okay, you can evaluate it that way. And that makes it a really nice way to evaluate things if you remember how to relate those together. Okay, so what the remainder theorem says is, if a polynomial function f of x is divided by x minus c, then then the remainder is f of c. So we use synthetic division, and it's synthetic because it's like artificial, right? Just like if you have synthetic oil, it's like an artificial oil. It didn't really come from the dinosaurs or whatever. So we have synthetic division because we're not physically dividing. We're doing other things that the result is what we get when we divide. So when you use synthetic division to evaluate a function, it's called synthetic substitution. Because we didn't actually substitute, but the result is what we would get when we do substitute. Okay. Any questions at all? It's pretty handy. All right. Okay, so let's do another example here. So this says we're given this function, and the remainder when f of x is divided by x plus 3 is negative 20, and we want to find k again. So on the outside, do I put negative 20 out here? Out here on the outside of my house? No, it's negative 3, right? So negative 3, and then in the house, Oh, trying to draw straight, but it doesn't always happen. I'm going to put 1, 8, 12, negative k, and negative 14. Okay. Then I want to double check, it's x to the 4th, so I should have 5 numbers. I do, just in case there was a missing something. Do I know the remainder here? Yes, it's negative 20. So I have a question for you then. What is f of negative 3? Negative 20. Because they told me what the remainder is, that's where this comes from, right? Now, that's not what this question is asking. That was my separate little question. But we know that f of negative 3 is negative 20. Okay. All right, so now let's find k. Actually, you go through, do your synthetic division, and find k. So don't just copy down what I did. Finish before you look up here. But once you're done, check yourself with me. If we don't agree, see if we can figure out where we don't agree. What questions you got? Anything? Okay. No questions? Still writing? And let me just say this. If you'd have put negative 9, I'm sorry, no, that would have been wrong. If you'd have put negative k plus 9 here, that's fine. And if you had this first and then minus 14, all that's fine. Like, it can look a little bit different along the way, but the work would be the same and the answer should be the same in the end. Okay? We're all good? We can move forward? Okay. All right, so then let's talk about the factor theorem. We've actually talked about it a few times. We just didn't really write it in words. And so if I say, if we are given a polynomial f of x, then x minus c is a factor if and only if f of c equals 0. Okay, so given a polynomial f of x, x minus c is a factor if and only if f of c equals 0. And so I've stated that a few times as we've been dividing the last couple of days, saying basically what this is saying is if it divides evenly, it's a factor. If it doesn't divide evenly, then it's not, right? Because if it divides evenly, my remainder is 0. And remember, f of c gives you the remainder. So if my remainder is 0, then we're good. So if we look back up here, when we divided this by x minus 9 clearly not a factor of this function because my remainder is not 0. Here, x plus 3, not a factor because my remainder is not 0. All right. So let's look at number 4. This says, given this polynomial, and x minus 7 is a factor of f of x, then what is the value of k? Okay, so we're going to do our synthetic division again. We're going to put 7 on the outside. On the inside, I'll have 2, negative 7, negative 53k, and I should have 4 numbers, so I'm good. All right, so since I have k in there, I need to know what my remainder is. What's my remainder? It doesn't say. What is it? 0. How do we know it's 0? Is a factor. Since it is a factor, then I put 0 here. Because on the other ones, it had to give it to me because it didn't say that they weren't factors. It just said this is the remainder, which means it's not. But it doesn't give me a remainder in so many words. Like it does, it's just in words. Oh, wait, it does give it in words. It gives it to me in words instead of numbers. All right, so then let's go through and find k. Bring down my 2. This gives me 14. This gives me 7, 49, negative 4, negative 28. So then is finding k going to be really easy or really difficult? Really easy. K minus 28 equals 0 is my little equation, so k equals 28. Any questions at all? All right, then you do number 5 on your own. So when you're done, check yourself with me. Don't just copy mine down. Why is it negative 2 right here? Because I do negative 2. Oh, whoop. Oh, it's not negative 2. Thank you. I don't know. That's a very good question. I have no idea why it's negative 2. Because it's 2. Thank you. Wanted to see if y'all were paying attention. Wanted to see how many of you would just erase your answers because it didn't match mine. Doesn't mean that I'm always right, unfortunately. I did, however, last period have a couple of students want to think that I was wrong, and I wasn't actually wrong last period. And they both got the same answer, and their answer was negative 6. But here's what they did. They didn't do this, which, first of all, is what you have to do. Maybe not every single step, but you have to show your algebraic steps, because remember, just because you can do it in your head, nobody cares. They were doing it in their head. They went over here, and they were like, all right, well, if I put negative 6 in here, negative 6 plus 2 is negative 4 times negative 2 is 8. They're 100% right about that. I don't know why they want that, though, because they were trying to match this number, but that's not what's happening here. So you can easily reason your way around things completely wrong just because you think it's easier to do it in your head. When this is not only safer, but you have to show it anyway. Like if they'd have just given me even just 2, I wouldn't have taken it because where the heck did that come from? Like you've got to show your process. Okay. What questions you got? Anything? All right. So let's look at number 6. It's a little bit different in what it's asking because we don't get a k here. So they give me a function and they tell me that f of negative 5 equals 0. So then I want to find all the zeros of f of x algebraically, which again means if you can do it in your head, nobody cares. All right. So I can't factor this one by hand, first of all. So since I can't factor it by hand, I'd like to factor it by some division. What could I put on the outside of my little house? Negative 5. So if I put negative 5 out here, and on the inside of the house, how many numbers should I have inside? 5, because this is x to the 4th. Look how many terms I have. 1, 2, 3, 4. So I got to figure out before I start writing stuff down which one I'm missing. I have x to the fourth, third, squared, first. I'm missing my constant term, right? That one matters too. I have to put a placeholder. So I have 3, and then 5, then negative 42, then 40, and then I have to put the 0. If I don't put the 0, then my basement's in the wrong place, and that throws everything off. Okay? We good with that? Do I know what my remainder is? 0. F of negative 5 equals 0, right? So if I'm going to use negative 5 here, that means my remainder is 0, which knowing that at the beginning of this one isn't as important because there's no k, but it kind of helps you with, I should get 0 there. All right, so then let's just run through our division. I get 3, negative 15, negative 10, 50, 8, negative 40, 0, 0. Okay. If I hadn't put this placeholder here, I still would have, that means like this whole column would be missing right here. I still would have gotten 0 here like I expected to, but it throws off what this answer actually is. Make sense? Because I don't have as many terms as I need. All right, so we know that this right here gives me, let's see, there's 4, so this would give me 3x cubed minus 10x squared plus 8x, and then plus 0, right? That's what this gives me, but we're not going to put the plus 0. My goal here is to get this factored and then find my zeros. So f of x equals, well, what would I have to multiply this by to get this back? X plus 5. Good. So since this is, since f of negative 5 is 0, that means that one of my zeros is x equals negative 5, which means that x plus 5 is a factor. So I'm going to start off with that x plus 5 times what I got from here, which is 3x cubed minus 10x squared plus 8x. So I've started off my factoring using this, so now I need to continue my factoring. And here, do I have a GCF? X. Okay, so I'm going to go ahead and factor that out. I'm going to bring it all the way to the front because it just helps make things look better. So I've got x times x plus 5 times 3x squared minus 10x plus 8. Okay. So then I would have to factor this. F of x is equal to x times x plus 5 times 3x minus 4 times x minus 2. Okay. That's what we get. I'm not going to give you time to factor because those of you that can factor, just your eyes are rolling back in your head and I don't blame you. Those of you that can't factor, you just got to get it figured out. I don't know what to tell you. All right, so now that it's all factored, I need my zeros. Or actually, let me ask you this. How many factors do I have? 4. Don't forget about him. He's important. I have 4 factors. Okay? Don't forget about this one. He matters just as much as the rest. So my zeros, what's the smallest one I have? Negative 5. And if I didn't have a negative 5 in there anywhere, shame on me because I knew that from the beginning, right? I knew that what one of them was. Then my next one would be 0. Then the next one would be 4 over 3. And then 2. Okay, and so it says, find all the zeros algebraically. So basically I had to show this because that was my algebraic part, but then those are my zeros. Okay, what questions you got? If the factoring is still freaking you out, go back to those factoring assignments that are still sitting in Delta Math and do more drill and practice. Okay, I know most of you don't need it. You're totally fine with it, but those of you that do, I mean, we're factoring some with synthetic division, but again, it's not going away completely. All right, any questions at all? Awesome. So go ahead and fold and tape and get started on your Delta Math.